CS 23 or CS 1535. Let's start. Let's start with the laser topic. Index, introduction, characteristics. These are index, interaction with radiation with matter, inside interaction, induced absorption, spontaneous absorption, stimulated absorption, and the last concept is Einstein emission coefficient. First, let's go to introduction. Laser is an encope for light amplification by stimulated emission of radiation. The first laser was built by Theodore H. Maier in the year 1960. Thus, it finds various applications starting from industries to communication. Interaction of radiation with matter. The interaction between radiation and matter occurs through the following three processes: induced absorption, spontaneous absorption, and stimulated emission. Induced absorption. When a photon of right energy is incident on the atom, then photon is absorbed. This process is known as induced by photon and hence is called as induced absorption. Consider an atom in the lower energy state E1. It will be excited to a higher energy state E2 by absorbing the incident photon on the energy E is equal to h nu is equal to E2 minus E1. Hence, E1 energy of the lower energy state, E2 is the energy of the higher energy state. H is Planck's constant, V is equal to frequency of photon. Spontaneous emission. Spontaneous emission is the process of emission of photon when an atom transits from higher energy level to lower energy level without the influence of any external energies, excited state, ground state. E2 is the excited and E1 is the ground state. This is spontaneous emission diagram. You have to draw this. An electron in the higher energy state of an atom makes a transition to a lower energy state without the action of any external agency. The energy of photon emitted is given by E is equal to h nu is equal to E2 minus E1. In this process, the emitted photons need not to travel in the same direction, thus the light beam is not directional. Now we'll go to stimulated emission. When a photon of suitable energy interacts with an atom in the higher energy state, then the atom is stimulated to make transition from higher energy state to a lower energy state with emission of photon. Both the incident photon and the emitted photons are coherent and travel in the same direction. Thus, the process is called a stimulated emission. Excited state and ground state. This is the diagram you need to draw. Stimulated emission diagram. When a photon of energy h nu is equal to E2 minus E1 interacts with an atom in a higher energy state, the stimulated emission takes place with the emission of two photons of the same energy that are highly directional and coherent. Thus, the stimulated emission could be to generate a higher coherent directional beam of light. Now, Einstein's A and B coefficient of expression for energy density. Consider a system of containing n atoms and is under thermal equilibrium. Let E1 and E2 be the lower and higher energy levels that contains N1 and N2 number of atoms, and respectively let the incident energy density of radiation be in eV. Hence, the system absorbs and emits the energy through the following process. The energy of the photons absorbed emitted by the atom is equal to h nu. Rate of induced absorption. The rate of induced absorption is defined as the number of induced absorption per second unit volume time Rate and absorption depend on the number of lower energy state N1, the number of atoms in the lower energy state, the incident energy density EV, the rate of induced absorption N1 into EV. Second one, the rate of induced absorption that is equal to B12N1 EV. Thus, B12 is proportionally constant to Einstein coefficient. Rate of spontaneous emission, the number of spontaneous emission per unit volume in the unit time is called as rate of spontaneous emission. Rate of spontaneous emission depend on since spontaneous emission on a voluntary process is independent of energy density EV, the rate of spontaneous emission depend on the number of atoms in the higher energy state, and N2 does rate of spontaneous emission N2 rate of spontaneous emission A21N. Hence, A21 is the proportionality constant called Einstein coefficient spontaneous emission. Rate of stimulated emission. The number of stimulated emission per unit volume in unit time is called as rate of stimulated emission. Rate of stimulated emission depend on number of atom in the higher energy state N2, the energy density EV. Hence, the rate of stimulated emission N2 EV, rate of stimulated emission B21 N2 EV. Here, proportionality constant is B21. Rate of stimulated emission N to EV rate of emission. Okay. Under the equilibrium, total energy of systems remain unchanged. Hence, rate of absorption is equal to rate of emission. Rate of induced absorption is equal to rate of spontaneous emission plus rate of stimulated emission. This is how you have to do the derivation. Here, h is the Planck's constant, and nc is the speed of light, and c is the speed of light. Vacuum, lambda is the wavelength of photon, k is Boltzmann constant, T is absolute temperature, and substituting of N1 and N2 in equation 1.4, we get EV is equal to A21 by B21, 1 by B12 divided by B21, and then E h nu by Kj minus 1. According to Planck's radiation law, equation for energy density in frequency domain is given by E is equal to 8 pi h v cube divided by c cube 1 by E h nu by Kj minus 1. On comparing equation 1.7 and 1.8, we get A21 by B21 is equal to 8 pi h v cube by 3 cube. B is equal to B12 by B21 is equal to 1. AB is equal to A by B 1 by E h nu divided by Kj minus 1. This is the last concept we got to study now. Yes, the last concept. Laser action and the conditions for laser action. Consider a laser system. Let an atom in the excited state is stimulated by a photon of right energy so that the atom makes stimulated emission. Two coherent photons are obtained. These two coherent photons stimulated two atoms in the excited state to make emission for four coherent photons are emitted. Thus, these coherent photons stimulate four more atoms. This causes lasing action. Next slide. This is the diagram